Hi, welcome to Advanced Math, Trigonometric Identities and Formulas, Classwork Part C, pages, all of them, pages 1 and 2. As usual, I really encourage you to take a stab at this on your own in the classwork and to come look at the video if you get stuck somewhere, you wonder maybe what I was thinking. The first page doesn't have any work for you to do, but there's lots of stuff to talk about. Part C and Part D are going to be dealing with the tangent and trig identities. Now, actually, Part C, what we're going to talk about isn't truly an identity. It's just a term called angle of inclination, and we want to look at how that relates to the tangent. Part D will have an identity related to tangent. So you remember on a unit circle that the tangent of an angle is the measure of its slope of the terminal ray of the angle. So for example, if you drew a unit circle and you had some ray, the angle like that, measured counterclockwise from the positive x-axis, if you took the tangent of that angle, it would be the slope of that ray. Now, when we talk about finding the angle of a line, and that's actually one of the really cool things about trigonometry is it's relating angles to things like slopes. If we had an xy coordinate system and we drew a line, line as in y equals mx plus b, and now we could ask ourselves the question, well, what's the angle of that line? Now, if you looked at that line angle-wise, just the slope of it on a unit circle, you could say, well, for that particular slope, there are two rays on the unit circle that have that slope, and therefore you could argue that there are two different angles that you might want to cite as being the angle of that line. Now, when we have a line like y equals mx plus b, it really would be nice to say what the angle is, not what are the two angles, or not even what are the angles and all the coterminal angles. We just want what's the angle of the line. And so that question, what's the angle of the line, is what angle of inclination really gets into. So the relationship, of course, we are going to continue to have the relationship that we had on the unit circle, which is that the slope of a line will be equal to the tangent of the angle of inclination. So the angle of inclination will be closely related to the angles that you saw in the unit circle. And this relationship will hold true. Just as that relationship held true in the unit circle, it will continue to hold true for angle of inclination. So scooting down to the bottom of the first page, we have an example. So here's an equation for a line, 2x minus 3y equals 21. We want to find the slope of this line, and we want to find the angle of inclination of a line. So without going into too much detail, to find the slope, you need to rewrite, or one approach is to rewrite the equation in slope-intercept form. That's what this algebra is showing you here. So this equation in y equals mx plus b form is equivalent to this equation in standard form. So now we can see that the slope of the line is 2/3, rise over run. And since the slope is equal to the tangent of the angle, we could write the equation like this. The tangent of this angle of inclination is equal to 2/3. And so to get the angle, theta, you just need to use the inverse tangent function. In this case, it would have to be on your calculator since 2/3 is not one of the slopes. It doesn't correspond to the slope of anything on our unit circle. So if you do that out in your calculator, you get 33.7 degrees. Now, the angle of inclination is always measured as a positive angle from the line to the x-axis in a clockwise direction. So, for example, if I suppose I had a line that look like this, with a negative slope. The angle of inclination would be measured here. Now, the kooky thing about this is when you go to do the inverse tangent of this negative slope, the inverse tangent function is going to give you this angle as a negative. All right. And we need to take that negative angle and convert it into this, whoops. We need to convert it into this positive angle. So again, the angle of inclination is always measured from the line clockwise to the positive x-axis, or the x-axis that's to the right of, in the positive direction from where it intersects with your line. So in every case, no matter what your line is, unless it's, well, I guess the horizontal line would be an angle of 0, you can always find this positive angle measured to the x-axis. And just remember that your calculator is going to give you, in this case, a negative angle. And in this case on the left, because the slope is positive, your calculator, when you do the inverse tangent, will give you a positive angle. And if that's the case, you just leave it. Like, that's the angle. If you do the inverse tangent, you get an angle and say, that's my angle of inclination. If you do the inverse tangent and you get a negative angle, you have to do a little bit of arithmetic to get this angle. Now you can see, of course, this angle and this angle add up to 180 degrees. So if you got like negative 20 here, that's a 20-degree angle. The other one must be 160 degrees. That's all there is to that. Just to zoom out. Okay, let's go to that. So here we have some examples to do. We want to find the slope of the angle and the slope of, I should say, the slope and the angle of inclination of the line 3x plus 2y equals 4. So let's do a little work on, oops, I don't want to use that color. How about blue? I like blue. We have 3x plus 2y equals 4. I want to get it to y equals mx plus b. Let's subtract 3x from both sides. 2y equals negative 3x plus 4. And that's going to be, let's divide both sides by 2. Y equals negative 3/2 x plus 2. Okay, so what's the slope? Well, once I've got it in y equals mx plus b form, there's my slope. So I'll just record that. It's negative 3/2. Therefore, remember the tangent of an angle, the tangent of a ray, or the tangent of the angle of inclination is the slope. So I could say, therefore, that the tangent of theta, the angle of inclination, is equal to negative 3/2. And to find theta, I'm going to be taking the inverse tangent of negative 3/2. And the way inverse tangent works, if you give it a negative slope, it's going to give you a negative angle. And we need to do some interpretation on that. So the angle that I get from the calculator is going to be negative 56.3 degrees. Right? And so, yes, indeed, the classwork says, be careful, did you get a negative angle? Well, yeah, I got a negative angle. I got negative 56.3 degrees. Well, that's this angle here. Because it's measured clockwise from the positive x-axis, that's going to be a negative 56.3 degrees. So this other angle over here, the one that we really want, that's the angle of inclination. Basically, what the angle that when added to 56.3 gives you 180. Or, very simply put, I could take 180 degrees and add this negative angle or subtract it, however you want to look at that, and I'll get 123.7 degrees. That is my angle of inclination. All right, so question 2 is slightly different. It's going to work the other way. Let's suppose, and I'm going to draw a little sketch here. When I put myself in pen mode, I'm going to draw a little sketch here. Is my axis system, and here's this point, 4, 3. And I want to find the equation of a line that goes through 4, 3 with an angle of inclination of 14 degrees. Now, the angle of inclination of 14 degrees means 14 is a pretty small angle. It's going to be kind of close to being horizontal with a slight upward slope. And just as a sheer guess, it's going to look something like that. I want this angle here to be 14 degrees. Okay, so the line could look something like that. All right, so remember, to get the equation of the line, I'm going to need the slope, I'm going to need the y-intercept. The slope, if you think back to the previous page, is equal to the tangent. Slope equals the tangent of the angle. Well, I know the angle. It was given to me right here. It's 14 degrees. So the slope is equal to the tangent of 14 degrees. Which, if you do that in your calculator, is pretty darn close to 1/4. So I'm going to call it 1/4. So rise over run is 1/4. So use the slope-intercept equation to solve for b. All right, so I know my equation is going to look like y equals 1/4 x plus b. And I know that this line passes through the point 4, 3. So that means that I know a y and an x value that work in this equation. In that case, it would be 3 is the y value equals 1/4. The x is 4 plus b. So I have 3 equals 1 plus b. Therefore, that's a plus. B equals 2. So the y-intercept is 2, or the b value is 2. So the final equation for a line is going to be y equals 1/4 x plus 2. And there we have it. So we've had an example where we're given a slope, both positive and a negative, and we come up with the angle of inclination for either of those. One's very simple, one requires just a scooch of extra work. And we have an example where we're given an angle of inclination, and we need to come up with a slope, and in this case find the equation for a line.